Okay, we've got a question about a race. We've been given a distance correct to 0.1 of a kilometre and a time that the race was run correct to the nearest second. And we've been asked to consider the speed. And we need to quote that speed at a suitable degree of accuracy. So let's look at the distance first. The distance quoted is 10.6. So what would be the next value up from this, considering that we're only measuring it to 0.1 of a kilometre? Well, the next one up will be 10.7, and the next one down will be 10.5. The barriers between our choices will be halfway in between, because anything above the barrier would be sucked into 10.6 and anything below the barrier would be sucked back down to 10.05. So this is the lower bound, and this is equal to 10.55. And the upper bound, which is here, is equal to 10.65. Now let's do the same thing for the time. So the next one up will be 31 minutes, 49 seconds. And the next one down will be 31 minutes and 47 seconds. Once again, the barriers are halfway in between. The lower bound is equal to 31 minutes and 47.5 seconds. And the upper bound is equal to 31 minutes, 48.5 seconds. Now, if we want the upper bound of speed, which means we need the upper bound of distance, but the lower bound of time, because after all, if time is lower, the fraction goes up. So the upper bound of speed, we need the upper bound of distance divided by. Now, the speed is going to be quoted in kilometres per hour, so we're okay for the distance, but we need to convert these two guys into hours. And the lower bound in hours, if you work it out on a calculator, is 0.529861 hours. And the upper bound, if you work it out again on a calculator, is 0.530013 hours. So, as I say, using the lower bound, this is 0.52986. And this turns out to be 20.0996. So the lower bound of speed, we take the lower bound, which is 10.55, and divide that by the upper bound of the time. And this turns out to be 19.9004. Whatever degree of accuracy we choose, these two results must turn out to be the same. If we try 3 significant figures, this turns out to be 20.1, and this turns out to be 19.9. And that's clearly still different. So if we try 2 significant figures, this turns out to be 20. If we now do the same for the lower bound at 2 significant figures, we get that 2 significant figures is equal to 20. And this is kilometres per hour. And you can see that at 2 significant figures, the speeds are equal. And there you are.